Hi everybody. Today I start periodic table, and we study inorganic compounds, and we would like to study about the chemical and physical property of the elements. Today I will speak and start with the metals. The first groups of the metals are alkali metals. Alkali metals are in the first group from the left under hydrogen, and they are lithium, sodium, potassium, rubidium, cesium, francium. Okay, and the electron configuration of this group is ns1. Okay, alkaline metal, as you see, valence shell electron configuration is ns1, and they are soft metals. We can cut it by the knife, and the low density, they are on the, if we put it on the water, they can stand on top of the water, and they have a low melting point, for example sodium around 97, and they would like to lose electron to become the noble gas before them, and because of these they are stable noble gas like cations. For example, sodium gives one electron and become sodium cation. Because of this loss of electron to the other compound, they are strong reducing agent, because they give electron to other compound and reduce them. We cannot find them in the element form in the nature because they are very unstable, and they even react with water and oxygen. They are oxidized very fast in the air, and also they can react very fastly with water, and they burn in the water, and because of this we keep it in the petrol or the oil. Okay, and also accumulate in the sea, in seawater, in the salt form. We can find this many types of this cation in the seawater. One of the important things about this group, they have a different flame test. For example, lithium has a red, sodium has a yellow, and the potassium has a purple colors. And one of these things, the qualitative test for the recognition of this group, we can use flame test. The first element of this group is lithium. Okay, it is a 2s1 electron configuration, and in the valence shell it has 2s1, and it's a very soft metal and the lightest metal in the world. Is very important, no biological important, but we use in medicine as a medicine, because for the medical use we can use lithium plus for the bipolar disorder or manic depression. And this component of the lithium hydroxide is strong base. It is very good compound in the battery. Okay, it is very important compound in the battery, and we will study later about this property. Okay, and usually it is very reactive element, and it is very unstable also. Sodium and potassium, okay, chemical very reactive, strong reducing agent. Okay, and as you remember, they are ns1. One of them is 3s1, other 4s1. They are stored under the petroleum or oil to avoid oxidation and reduction in the vapor. They can react with oxygen, and depend the amount of oxygen and the type of oxidation, they can produce 3 types of the oxide. 2 types is here. Sodium can easily oxide with oxygen and formation of sodium peroxide, or also sodium can react with the oxygen to produce sodium superoxide. Also, normally sodium can react with oxygen to produce sodium oxide. Okay, it is a sodium oxide. Sodium superoxide and sodium peroxide, okay? And also for the potassium, we can produce potassium superoxide, we see here reaction, or we can write potassium plus oxide. Potassium can produce, we here also we need to balance it, sorry. And if we can produce potassium peroxide, and also potassium can react with oxygen to produce potassium oxide. Okay. These compounds, for example, this sodium oxide is very easily, fastly can react with water to formation of the base. Okay, for example, or potassium. If you go to the next page, I will write here, for example, when oxide the sodium, normal sodium is to become Na2O. Na2O, sodium oxide, can easily react with water to formation of the sodium hydroxide. It is a very strong base. Okay? And also potassium is also like this. With the potassium, we can also produce K2O, and the K2O, potassium oxide, can react with water to formation of the potassium hydroxide. They are very strong base. And also lithium can oxide, which I didn't write, to formation of lithium oxide. Sometimes we can produce also lithium peroxide, and also sometimes very rare we can produce lithium superoxide. Okay, and also it's very normal if we react lithium oxide with the water, we can produce lithium hydroxide. It's very important compound. Also in the battery we use this compound. Okay, as see here, we keep it in the oil. As you see here, reaction with water. Okay, directly can react with water. Sodium with water can produce sodium and hydrogen gas. This hydrogen gas, we can collect it as a hydrogen gas. Or with the potassium also we can produce base, strong base, and hydrogen gas. And sodium and potassium, it's the hydrogen reducing agent because they give an electron. They are strong reducing agent, and also we have a dehydration in the biological importance, central role of the osmotic and pH regulation. Also, we can use this compound. Also, we have a weak complex, play a role in the maintenance configuration of macromolecule. And also sodium and potassium, very important in the action potential. In the action potential, and we have very important role in the action potential, and it's very important. And we studied last time about the spectrum, okay? And if you see sodium spectrum has a D line. Also, if you see it is a frequency, if you see 589 frequency, and we see the spectrum in the light on it. Okay, compound. The first one is about alkali hydroxide, sodium hydroxide, potassium hydroxide, lithium hydroxide. It is a very strong base. And the solution form of them, sodium chloride, it is a table salt. We can find the sea salt, biologically important, which is the electrolyte component of fluid, also used for preservative and seasoning, and also physiological saline solutions with very important 0.9 mass volume percentage of the solution we use as the infusion is very important. The second one, sodium carbonate. Sodium carbonate is a washing soda. It is aqueous solution is basic. If we heat this compound, we produce carbon dioxide, can produce Na2O, sodium oxide, and sodium oxide again can easily react with water to formation of NaOH. Sodium hydrogen carbonate, or also baking powder, we use in the baking powder or antacid and filling in the fire extinguisher. And also decompose when heated, okay, again, if we heated the same situation, produce sodium carbonate and water and carbon dioxide. And also, if we continue heating again this compound, it goes to this direction. If we have air in the water or humidity in the water, it is also important. Filling the in fire extinguishers, it is for the prevent fire, for stop the fire. It is a very good situation for it can help to for stopping the fire. Potassium chloride, it is more stable than sodium chloride. Top layer in the salt mines is very important. Supplementing the potassium deficiency. Usually potassium deficiency happen by the vomiting, because in the stomach we have a potassium proton pump for the formation to secrete the acid. And these potassium proton pumps, when we have a high amount of for example, when we have vomiting a lot, in this case the potassium decreasing, also sometimes diarrhea is also possible. The second group is alkaline-earth metal, okay? They are very important. Why is earth? Because we can find in the earth in the high amount, and also they are alkaline group, can make alkaline. They are a good base. The electron configuration, last valence shell, this is NS2. And the stable form to loss of electron, for example, magnesium loss to electron, become magnesium 2+, and also calcium the same. And also they are very strong reducing agent because they give electron for other compound. Flame test is very important. For example, calcium has a brick red and strontium is red. Barium mostly green. Okay, we can find the difference between the flame test also. The first element is the magnesium. If you see the magnesium also, it is the last electron layer has a S2. It is S orbital is the full. Okay, and it has a silvery light metal. Auxiliary form is surface of the metal, usually, if you see here. Biological importance is very important because it is central ion in the chloroform in the green plant, chlorophyll, and also a chlorophyll in the plant because it makes photosynthesis the plant. It is an enzyme activator. It is we say cofactor. And also we have a magnesium carbonate. This is a sticky water soluble powder. Usually we use in the sport, for example, in the bodybuilding or in the space, in the sport, because of the grip improving agent for the keeping something also for the sport. Okay, and magnesium carbonate also, if we heat it, it can produce magnesium oxide and carbon dioxide. Magnesium oxide easily can react with water and produce magnesium hydroxide is a strong base. And the second element, again, it is a calcium. It is again NS2. The last valence shell is a 2 electron in the last valence shell. And the biological importance, second messenger in the cell, because, for example, mechanism of G protein copper receptors which produce IP3 dog, and from IP3 dog, and we can increase the amount of the calcium ion. Okay, blood clotting, one of the important factor in the blood clotting, muscle contraction because of the muscle function, because of the active myosin activation also is very important. Also, it is very important, as you see, we have other function also like a neurotransmitter release, okay, in the synapse. Okay, neurotransmitter release in synapse. Or plateau phase in the action potential of the heart is very important. The plateau phase, for example, if the heart action potential, it is a depolarization, sodium open. Plateau phase, calcium open. Repolarization is the potassium open. If you see here the sodium, here is the calcium, it is the potassium. It's very important, action potential heart. One of the important things is the calcium carbonate. It is, we can find the burnt lime. It is reacted with water very easily and produce calcium hydroxide. Calcium hydroxide strong base, moderately water soluble. Okay, it's very important. And the calcium carbonate, it is we can find the chalk or limestone in rock, bone, eggshell, and the composition again with the heating, they can produce calcium oxide. With calcium oxide, we can again react with water to formation of calcium hydroxide. Barium is very poisonous. It's very poisonous. It can very dangerous and can kill very easily patients, people. But we use because it's a barium, it can lose electron and they become barium 2 plus, very poison. And but barium sulfate, it is a barite. It is a very, because it's insoluble in water, and we got use radiology in the X-ray for in the GI tract, because it's high atomic mass number, efficiency to absorb X-ray. How we can produce this one? We usually produce with barium chloride, with for example sodium sulfate. It can produce NaCl plus BaSO4. It is a precipitation, then we can remove very easily. The last group 3 is aluminum is a metal, as you see, and it has the electron phase. It's Ns2 and Mp1. In the last valence shell, it has a 3 electron. Okay, in the ground state, it has a 2 electron in the S and the 1 electron in the P. But because of the promotion, 1 electron jump in here, we can have a 3 electron, okay? NS1 and MP2. But if we have an electron, if we have a hybridization also, it can possible we can produce sp2 in the 3 situation. It's a soft and silvery and durable metal of low density. It is a very good things in the aluminum because of oxidation layer, okay, protect the metal. And because of this, if you see the new aluminum are very silver, but if the old aluminums are a little darker because of the aluminum oxide. It is a good conductor. Alloys with other metals are widely used in the industry because of the aluminum is mainly soft, but with alloys will be harder. It can use in the very big industry, like for the formation, for the production of the airplane or other things. They are amphoteric. Amphoteric is the reaction with acid and the base. They can produce both of them. For example, here the HCl is acid. Here is the aluminum is the base. And they can produce aluminum chloride plus hydrogen or gas, okay? But in the second reaction with the sodium hydroxide is the base. Here is aluminum is acid. And with the water help, they produce sodium tetrahydroxoaluminate. It is a complex, it's very important. And also production gas, hydrogen gas. Sodium tetrahydroxoaluminate can easily in the water produce, it can produce ion form, okay, ion, it is a electrolyte, and the formation of the ion form, complex ion, and sodium ion, okay. Component of aluminum is aluminum oxide, okay, I say it is very important because usually it is a layer of the first layer of the aluminum. It has a very high protection about aluminum to destroy aluminum. It's not like iron after oxidation it is very soft and destroy the iron metal, but here the aluminum oxide is very hard, water insoluble substance, and can protection, but it has amphoteric. It can react with acid and base here, because HCl is acid. Here is the base and produce aluminum chloride with water. But here is because aluminum hydroxide is base, aluminum oxide is the acid, and with water again produce sodium tetrahydroxoaluminate. Aluminum hydroxide also is insoluble in water. It is a basic compound, okay, and it is amphoteric. It's very important. With the acid for the production, we can use aluminum oxide with the water. We can produce it aluminum hydroxide. Okay, 2 here because we have it here, and we have a 3 here. Okay. And it is amphoteric, and if we have amphoteric, for example, if here is the HCl is the acid, is aluminum hydroxide is the base, produce aluminum chloride. Also here aluminum hydroxide is the basic, aluminum hydroxide is here is the acid rule, and again produce sodium tetrahydroxoaluminate. Also we have another compound which name is aluminum chloride, because aluminum chloride has the free orbital. It is very important for the Lewis acid, because Lewis acid is electron pair acceptor. It has a covalent electron and deficient compound. It's very easily accepted. For example, I write example here. AlCl3 can react, for example, Cl minus become AlCl4 minus. As you see here, it has electron pair. Okay, and aluminum chloride has a free orbital, then can form it is a very Lewis acid, and it's very important in the organic reactions. And the next group is the D transition metals. Okay, D transition metal is very important. It is between the S and P. If you see it's the first group, first period, second, 3, 4, 5, 6, 7. Okay, here start, for example, potassium start is the first one, calcium is first 2. But after you go to the transition metal, it start to decrease. D is decrease the 3, Y is the 4, Li is 5, AC is the 6. It's 1 less. For example, if you see here, it's very important. Okay. 3D1 forest 2. Okay, it's very important. We can feel the orbital one by one, but there is a big difference in the 4 here. First the filling of the D, then will be 3D5, then forest 1, and the last before last in the 9, 3D10 and the forest 1. Both of this group is important. We know in here both of them first filling D, then filling S. Okay, it's very important. Okay. Okay, and also outermost shell electron configuration from as I mentioned, M-1 D1 NS2 to M-1 D10 to NS2. High density and usually high melting points. There is an exception. For example, mercury is with low melting point, and the oxidation state can be different. They have a different oxidation number. For example, if you see here, vanadium has a 5, 4, 3, 2, and the different color for each of them is very good for the redox reaction, and we can speak about this. The first element which we can speak about is the manganese. Manganese in the 3D5 forest 2. Then in the 5 we have a 5 electron, and the S is the 2 electron. Okay, but orbital P is the empty, no electron. As you see here, if one electron jump from S here, we will have a maximum 7. Okay, very important. Then oxidation number we have a 6, 4, 3, 2. depends for the which electron we can use. Okay, one of the most important compound, magnesium dioxide, which magnesium here the positive 4. How is it positive 4? If I write MnO2, usually oxygen is -2, we can write Mn plus 2 times -2. Okay, and the molecule charge is 0 and the Mn is the positive 4. Okay, it is a brown precipitation, and the KMnO4 also, the here is the positive 7. How is it possible? Positive potassium is group 1 is always +1, Mn we don't know, and oxygen here is -2. All total is molecule charge is 0. Okay, Mn -7 equals 0. Mn is positive 7, excuse me. And this one is very important. It's strong oxidizing agent, and in the strong acidic solution, Mn7 convert to the Mn2. And we study about this, how we can write this reaction, how we can balance the redox reaction. Okay, I will explain this part now. Okay, for this reason I opened a new page. Okay, I write this example: Fe2 plus, MnO4 minus, H plus, Fe3 plus, Mn2 plus water. As you see, exactly the same reaction. First, we have to find oxidation number with the color. If the simple atomic ion, we can oxidation number is the same. It is a positive 2. Mn I found on the last page, but again I can find here. Mn plus 4 times -2 equal total charge of the molecule is -1. It is a -8. Mn will be 8 minus 1 will be 7, positive 7. I can write Mn is the positive 7. Oxygen is -2, proton is the positive 1, iron is because it is a free alone ion, it will be again the same of the charge, positive 3. It is Mn positive 2, hydrogen positive 1 with non-metal, oxygen here the -2. As you see here, we choose the two colors. We can choose between the brown and the green. Iron is I choose the brown, change, okay, from positive 2 to positive 3, 1 increasing, oxidize, okay. Oxidation happen here, or here Mn from positive 7 go to the positive 2, 5 times decrease, reducing. Now we change, we give a green to the brown. I can give here green here, and I can give the brown to green. Excuse my writer mistake. I have to green to brown. Now we are a green. We go to the brown, and we give the brown to green. Okay, brown to green. Okay, we change this one. Now, two of them is good, and we counted how many in the left side iron. We have a 5 iron, and we give a 5 here. Excuse me, I write with the same color. And how many Mn we have here? 1. We have put 1 here. Okay, now until here is important, and now we count oxygen. In the first line we have 4 oxygen, here no oxygen, no oxygen, here 1 oxygen, we put 4 behind it. In this situation I put 4 here, and we have to count hydrogen. Okay, here I don't know how many hydrogen, but here is I have 4 times 2 is 8. Here I put 8 here. Okay, it is important. This is a redox reaction, very important, and I hope if I try the next also lecture or next element, I'd find other example. And the second element which is very important for us, is iron. Iron is the 3d6 4s2. It has a 2 oxygen state. It's iron 2 plus, iron 3 plus. I can write iron can lose electron 2 plus, become iron 2 plus. Iron can lose electron for the 3 plus, become the iron 3 plus. Okay, 2 oxidation state, which one of them see we saw in the last example in the redox reaction. And also we can find the roast in the oxidation here, very important. Here the oxidation is the oxygen -2, this oxygen -2, hydrogen +1, iron must be +3. And the biologically important, we can find essential trace element in the hemoglobin, but it must be +2. Okay, in the myoglobin it is in form of +2, Fe +2. And it can go in the redox enzyme, works with the Fe2 plus to Fe3 plus. It's very important. The other element is cobalt in the cancer-therapy, which I mentioned, I think, second lecture or first lecture about isotope 60, cobalt 60 isotope it for use cancer therapy, and also vitamin B12. Okay, it is we can see structure here. It is inside the porphyrin ring. We see the cobalt ion. Okay, which helps for the stability of the vitamin B12. Okay, and thank you very much for this. Pay attention, and I hope to see you in the next lecture. And I hope these lectures can be useful for the medical student, and have a good time.